The random variable x has a normal distribution with mean mu is 50 and variance sigma squared is 16. A. Sketch the probability density function for x and shade the region representing probability that x is greater than mu minus 2 sigma and less than mu plus sigma. We should know the next about a normal distribution, that points of inflection, they are somewhere here and they are at mu minus sigma and mu plus sigma. And also you should know that area between mu minus sigma and mu plus sigma is, we can calculate, it doesn't matter what values for mu and sigma are. We can consider these values. Normal CDF lower, its mu is 50 minus 4, because standard deviation sigma is 4 square root of variance, and upper it's 50 plus 4 mu 50 and sigma is 4. It is equal to 68%. And if we consider plus minus 2 sigma, so minus 8 and plus 8, we can see that area and probability is about 25%. And if we consider 2 sigma, it's minus 3 sigma, it's minus 12 and plus 12. So within mu minus 3 sigma and mu plus 3 sigma, area is 99.7%, and it's very important that almost all data must be within approximately within mu minus 3 sigma and mu plus 3 sigma, so that a given data can be described or modeled by a given normal distribution. So it can be used as a criterion so that normal is a suitable model. And mu minus 2 sigma, it's about 95%, so it must be somewhere here, mu minus 2 sigma, and mu minus 3 sigma, it's somewhere here. So a required region, it will be from mu minus 2 sigma to mu plus sigma, which is a point of inflection, so this is not required. So a given region is this region, and we can find exact values. So mean is 50 and 50 plus 54, and it's 50 minus 2 times 4, so it's 42. So more clear, it looks like this: 50, 54, and somewhere here 2 times larger, 42. It's mu minus 2 sigma, mu plus sigma, and it's a given region, something like this. Maybe more closer to x. Okay, the next, find the value of probability that mu is that x is greater than mu minus 2 sigma and less than mu plus sigma. So we need this area. So if we know values for x, we can just calculate directly for x using that x is distributed normally with parameters 50 and variance is 16, and we can just calculate x is greater than 42 and less than 54. But in general, if mu and sigma are not given, to calculate like this, we can actually we have two ways. The first way, it's due to symmetry, but it's not symmetrical. We cannot calculate it due to symmetry. And another way, it's to use a standardized normal distribution and using z value, and z it's x minus mu divided by sigma, and hence the lower bound becomes x, it's mu minus 2 sigma, minus mu minus sigma, and we can see that we get just a number in terms of z, so it becomes -2, and z2 our upper bound, it becomes mu plus sigma minus mu divided by sigma, it's 1. Hence we need z is greater than -2 and less than 1 under z is distributed normally with parameters 0, 1. It's always 0, 1 for standardized normal distribution. It means we deal with z instead of x, and we just choose normal CDF. Mu is 0, sigma is 1, and lower it's -2, upper is 1, and we get the answer. It's 0.81, 0.819 to 3 significant figures. And let's check in terms of x. So inverse normal CDF, lower is 42, upper is 54, mu is 50, sigma is 4, and we can see that we get the same result. The next, find the value of k for which probability that x is greater than mu minus k sigma and less than mu plus k sigma is 0.5. So let's try solve it using symmetry, because it's symmetrical. Mu minus k sigma and mu plus k sigma, and area in between is 0.5. Hence this area plus this area is also in total 0.5. Hence this area is 0.25 and this area is also 0.25. And since mu and sigma are given, we can find this value in terms of x. So we use inverse normal. Area calculator always, my calculator always asks area to the left. So to find this critical value, this value of x, I need area to the left, and it's 0.25. So 0.25. Mu is 50, sigma is 4, and This value is 47.3 to three significant figures, and this point is mu, which is 50, minus k times 4 is 47.3. Hence k becomes 50 minus 47.3 divided by 4. So we can write the next 50 minus the answer and divide by 4, and we get 0.674 to three significant figures. And that's all for this question.